for this presentation. Like I mentioned, my name is Simerjeet Virk, and I'm an assistant professor and extension precision ag specialist with University of Georgia. And I'll be presenting about spray control system and technologies in precision ag. I'm a recent new faculty here and been working with the machinery systems and precision ag for almost 5 to 6 years now, and do the research and extension work on different type of machinery systems, anywhere from planting to harvest machinery and technology, and also work closely with growers on how different precision ag solutions or technology helps them in their operations, and also demonstrating the benefit or the advantages of technology adoption to help them promote or adopt the technologies on their farm. So the presentation I'm talking about is one of those technologies, is the spray control system and technologies, as this is mainly a technology. A lot of spray technologies have developed in the last few years, and our main goal is how some of these technologies can help these fruit and vegetable growers in doing a better job of applying crop inputs, at the same time maximizing the technology benefits. So to start with, I'd like to cover why do we need some of these new spray precision technologies, is because our conventional spray systems, when applied in the way they're built or designed, result in a lot of high off-rate application errors, and also they're not built where they would compensate for ground speed changes. Anytime you start spraying with a conventional spray system, you're supposed to set it up at a certain pressure and rate, and anytime there are variations in ground speed, we're applying either more or less material or chemical than what we intended to. And because of that reason, we do have a lot of flow and pressure variations during the application. And we also don't have the ability on these systems to turn the boom sections or the nozzles on and off in the areas where we don't need to spray. So therefore, overall, these systems are highly inefficient and non-uniform application, and that's why we need some of these precision spray technologies to do a better job of spraying. So I like to break these into two different categories: a standard technology, which is almost think a must-have technology today for any type of producer, and then the advanced technologies, which is more on depending on how much spray you usually do, how much coverage you cover, and also depends on the cost of the technology. So I'll cover these one by one today to show what each one does, how each one works, and how the growers can benefit from these by implementing on their farm. So when we talk about some of the sprayer types specific to the fruit and vegetable, now on the vegetable production, if you look at these top two sprayers, we use a lot of boom sprayers, where sometimes they're custom modified for certain operations, but mostly they're boom sprayers where we have nozzles aligned along a boom at a certain spacing. When we talk about fruit or orchard sprayers, we have these air blast sprayers, or what I call a vertical boom sprayers, where the nozzles are aligned either along in a semicircular or circular fashion or along a horizontal line. So the technologies I will be covering today are basically for both type of sprayers, whether it's a boom sprayer or air blast sprayer, and I'll mention which ones are currently available for which type of sprayer. The first technology, which I almost say is a must-have technology, is a rate controller, which helps us maintain the target application rate based in. So like I said earlier, anytime we're trying to do application with a conventional sprayer without a rate controller, we have to set a certain pressure, and we're assuming that we're applying that target application rate based on the ground speed. However, we all know that while doing the applications, there are a lot of ground speed changes that happen in the field. So a rate controller changes the flow of the liquid while we're spraying to maintain the target application rate based on changes in the ground speed. Even though the technology is being available for the boom sprayers for a long time, but we also have this technology available for air blast sprayers as well as the vertical boom sprayers. so the growers can utilize it to maintain the target application rate. The second technology I say must have is a section control, where in a conventional situation, if the boom is just plumbed as a single one section, then we can only turn on off the whole boom together. And usually when we're spraying, our boom is simultaneously going over sometimes the previously sprayed zone, or there are certain parts of the field where we don't need to spray excessive. So what section control does is we're breaking the boom into 3 to 4 or sometimes 7, 3 to 5 or sometimes 7 different sections, where we can turn these sections on and off separately. And what that does is helps us reduce the over application by turning those specific sections in previously sprayed or no spray zones. Now this also paired with a GPS system where the sections can be turned on and off automatically, or this is also available as a manual control, and again available for both the boom sprayer and also the vertical boom or the air blast, where you can turn off certain nozzles so we are not spraying, wasting or over applying the chemical. The third or the next technology here is the individual nozzle control, which comes into the advanced technologies, where it's the same principle as the section control, but now we're just refining the resolution of control here, or application, by instead of turning each section on and off, we're turning each nozzle on and off. Now this technology does come with a little bit of cost, because we're putting the capability to turn on off the nozzle on each nozzle instead of a section. So instead of the rate control valves, we use solenoids or electrical valves on each individual nozzles, and that's where the costs come into play. Next one, which is something similar to a nozzle control, but more for the orchard or tree growers, is a smart sprayer, a sensor actuated spray. What we're usually doing here is the system uses some sort of sensors to turn the spray on and off in orchards. In a conventional spray system, if we don't have this technology, the sprayer is continuously applying the product, which there's a lot of wastage, where even there are no trees, the product is being applied and it is getting off targeted or drifted away from the actual target. So what we're doing here is using usually any sort of combination or by itself a visual, infrared or ultrasonic sensor to turn the nozzle or the sprayers on and off only where the trees are present, and that equates about at least 25 to 40% savings in just the chemical. A little bit of advanced version of that intelligent spray control system is actually where now we're using a similar technology, but instead of just turning it on and off, we're using visual or LiDAR mapping to actually take into account the volume of each plant or the area of each plant. So the system uses a combination where it scans for each plant, and based on the plant tree height, area, volume, it adjusts the rate based on the canopy that is present there. As a part of some of the precision spray technologies, we also have the advanced nozzles or drift management nozzles. Typically, these nozzles are basically designed because we start to have a lot of issues with pesticides drifting into the sensitive crops or areas. So the manufacturers start manufacturing these air induction nozzles where they produce larger droplets which does not easily drift compared to some of the other flat fan and other nozzles, and these are mostly available for boom type sprayers. And one thing that when I say that be selective with the nozzles here is that the nozzles does provide improved coverage and reduced drift, but the grower should also look into the nozzles where be dependent, we selected with the nozzles on what type of application, whether it's a herbicide application, fungicide, insecticide. So choose the right nozzle for that option. This is again another one of the advanced technologies available today for the boom sprayers is the pulse width modulation. So even if we have a rate controller present on a boom sprayer, anytime the rate controller changes flow to maintain the target application rate in the field with ground speed changes, it adjusts the pressure to maintain the target application rate. And these nozzles that we utilize on the boom sprayers are very sensitive to changes in pressure because it changes the droplet size and it also changes the spray pattern. So the reason behind having this technology is that instead of changing the pressure to control the flow now, we're keeping the pressure constant so we can maintain the droplet size and the spray pattern throughout the whole application process. And what we're using to do that is these pulsing solenoids at each nozzle, which are controlling the flow by turning on and off. And we're maintaining that by assigning different duty cycles and frequency and keeping the same constant pressure. So this technology, besides providing us a rate control or maintaining target rate, also maintains the target pressure throughout the field during application. The next technology that's becoming more and more popular in boom sprayers is the Autoboom Height, where as you already know that we have a different type of terrains in the field. So when we're applying in the field, the boom height is not always consistent or where it needed to be, and depending on the terrain you can be really low or really high in certain parts of the field, which affects your application and coverage. So this technology utilizes ultrasonic sensors to sense the distance from the ground, and then those sensors are tied back into the control system where it maintains the optimal spray height in different type of varying terrains in the field or even at faster speeds. Usually there are 3 to 5 sensors mounted on the boom to attain that optimal spray height along the boom during the application. So this we're talking about here is a very as I mentioned earlier, with all these sensing technologies we have today, we're moving towards an automated spray systems where we're not having any human presence on board, or we're trying to do the operations automatically. So this is actually a spray on the top here, like global unmanned spray systems. It's an air blast system that is fully autonomous and uses different combinations of what I mentioned earlier, the LiDAR, vision, and guidance systems to control the material, the product application. And it also has the capability to turn the product on and off only when it's needed in the orchard. And some of the newer systems have also the capabilities where they can vary the rate of the product based on the canopy height or the tree canopy. So this is already available out today for orchards and that, but again, this is something that we definitely need to think about the cost of it, and on if someone's comfortable with this type of technology doing the work by itself. On the boom side, even though the concept has been floating around for a few years, we do not have yet an autonomous boom sprayer, but the bottom picture is what the deer showed, what their autonomous sprayer is going to look like in future. So it's coming for the boom sprayers. After I covered some of these technologies, I really want to quickly share what all is available or how growers can kind of take advantage of what technologies and how they can decide about some of the other technologies. So when I say some of the basic technologies, there are rate control, section control that I also say is a must-have technology. So this is something that every grower should think about adopting if they don't have it, or making the best use out of it. And these are also the must-have technologies, whether you're using a boom sprayer or you're using a tree or orchard sprayer. Be selective with nozzles again. Nozzle is one of the cheapest parts on the boom, so make sure you're replacing them as needed, but also using the correct nozzles based on the applications you are doing. When it comes to some of the other precision technologies, whether it's a variable rate application or visual or optical sensors, the grower should evaluate the chemical savings and the return on how much acreage are they spraying and what would that investment look like. While some of the vision sensors may be cheaper, but also are they comfortable using those technologies on the sprayer or making the maps if they need to be for those type of applications. The next step from there is the smart or intelligent spray systems, which is again really depend on, since these systems are expensive, are the growers comfortable in using that technology, plus are they spraying enough acres to justify the cost or investment in that type of technology. And then finally, the automation. Before thinking about automation, I think growers should think like, can they use some of the low risk technologies or get more familiar with some of the other autonomous systems that are available there for spraying systems. One example would be drones with spraying capabilities. Or is someone thought about using this autonomous sprayer? Are they comfortable enough using just a drone first to see if that technology really fits their operation? Plus, moving forward, are they comfortable using all that bigger technology? So before they make a huge investment in a fully autonomous machine or a spraying system. Lastly, I do want to emphasize that it doesn't matter how many technologies, precision sprayer systems we utilize on our sprayers, all of them does need to be calibrated correctly for them to do their job efficiently and effectively. So here are just some tools and technologies. The one you see on the very left hand is called a spot-on meter, where you can check the individual nozzle flow rate for each of the nozzles for boom sprayer, air blast sprayer, by modifying to collect the liquid. And there are also certain apps from different manufacturers here. The TJ Technologies, the TJ nozzle manufacturer, has an app called Spray Select, which helps you select what are the best nozzles for the type of application you're trying to do. And similarly, Clemson University has this Calibrate My Sprayer app, which helps you input different calibration parameters and tell you how far to drive, and also calculate, measure the actual and the target application rates to help you stay on target. So make sure you check some of these technologies or aids out, so you are making the best use of your spray technology and using it in the most best possible way. Again, I'd like to thank everybody for attending the presentation today, and I will be sticking around to answer the live question and answers from the audience if they have any regarding my presentation, or how they can help adopt some of these technologies, or if they have any questions about any of these specific technologies that I shared today. Thank you.